Okay, hello dear students. Today we are continuing discovering the alternating circuits, the circuits with alternating current. Last time we finished on the topic of basic definitions on electrical circuits. We discovered that any function in alternating case, in sinusoidal alternating case, will be a sinusoidal function with the main characteristic amplitude value, the maximum value of sinusoidal function. Here it is, maximum value, then total phase, all argument inside the brackets, and this phase consists of a frequency or the opposite value period, describe the oscillation of our function, and the initial angle, because our function could start from any point instead of zero. That is why any sinusoidal function has three main characteristics: amplitude, frequency, angular frequency, and initial phase angle. And if we are solving circuits with lots of elements, on each of element will be different functions, and it makes our calculation much more complex than in direct case. And that is why, for example, here it is, for some element we have two different functions with different angles, different amplitudes, and we should deal somehow with it. The first point that was previous time, just let's make quick revision before going to the next topic. First main point previous time, how to deal with a sinusoidal function, how to make our calculation more simple, then to solve, to find the working mode, to solve the equations in the period time in some average form. This average form named root mean square values, and it is average value on energy by period of time. It was found from the integration of function, but it is just an average value, and root mean square, here it is. What is the difference? The average value, it is an average of function, and always it equals zero because square under the graph function in positive and negative numbers are equal between each other. That is why the total integral of this function will be zero. But if we are speaking about power and energy, we are speaking about square of function, square of current, because power equals square of current multiply on resistivity, or square of voltage divide on resistivity. And if we want to obtain energy from the power, we should integrate this power per time. And in any case, the amount of work or the amount of heating or the amount of any consumption from electrical system will determine by the quadratic function. That is why after we integrating by period of time the quadratic function, we get in such called root mean square value, the value comparable with direct current case, and that is mean if we are taking sinusoidal value with root mean square that equal direct current, then by time equal to the period, we will get the same energy. It is the main characteristic of root mean square values. It means that if we have, let's draw it, if we have sinusoidal function for this period of time, and if we have direct alternating current sinusoidal case and direct current case. Then in both of these cases, if root mean square value equals the direct current case, then the power per period of time will be equals. Power on AC will be the same power on DC. It means, for example, if we are heating the electrical kettle on alternating current and on direct current, it will boil our water on the same time because we are consuming the same energy. It is one of the main characteristics of alternating current, such called root mean square value, and in all cases for voltages and for currents, it will be in square root of 2 smaller than amplitude value. For example, if we have amplitude current 10 ampere of the sinusoid, then if we are searching for average root mean square value, we should divide 10 ampere on square root of 2, and we will get just one moment. It will be about 7 amperes. 7.1 if more accurate, but generally about 7 amperes. And if we will take direct current 7 ampere, it will be the same power than alternating sinusoidal current 10 ampere. Then, also we finished on the idea that if all our functions are sinusoidal and we want to use our main laws, Kirchhoff law on current and Kirchhoff law on voltage, then if we are summarizing current values or voltages values using these laws, then we will always making algebraic operations on sinusoidal function. If we want to add, we will add in sinusoidal function. And it makes our mathematics more complex because we should use trigonometrical substitutions, trigonomical transformations, and it is not very comfortable case for calculation. That is why the second main idea to represent sinusoidal oscillations as rotation on the circle, because any instantaneous point of sinusoidal oscillation, for example, this point, could be represented as a projection on the vertical x. If we are speaking about H of sinusoidal function, about value about H on things of sinusoidal function, the same will be H of the point inside circle. For example, amplitude value will be the upper point of the circle, minus amplitude value will be the bottom point of the circle, and for any other point of the circle, we could point the same value point the same value inside the circle. That is why such representation will be true. What it gives to us? It gives to us that instead of sinusoidal function, we could use complex vector form as a vector circling in coordinate system. Why it should be complex? What does it mean? Complex, that it means then on the horizontal x will be real numbers, on the vertical x will be imaginary numbers, and this coordinate gives us complex vector. Why it should be complex? Because we want to divide the physical effects of different nature. Just one moment. That is mean we have two different effects. Consumption of electricity by transforming the electricity into another form, into the heating, light, chemical reaction, rotation, and other forms. All this will be consumption. And mathematically, it represented by real numbers, because some amount of energy disappear from our circle, or some amount of energy appear or came into our circle. And the same, and the second physical effect, the distribution of electrical energy inside our system without any disappearing or adding to it, just one moment. Just distribution inside our system. What does I mean? What do I mean under the distribution? That inside our system we have a storage of energy as a capacitor and coils, because capacitor have some amount of energy inside the electric field inside it, and coil stores some amount of energy inside magnetic field inside it. And coil and capacitor altogether gives us electromagnetical field inside system and some amount of energy inside this electromagnetic field. And this energy just flowing between all coils and capacitors, but stays inside our system. And for this effect, we are using imaginary values, imaginary numbers. And that is why in the complex plane, instead of sinusoidal oscillation, we are substituting complex vector. How it is made? We are taking amplitude value of our sinusoidal function and the initial angle of our sinusoidal function. For example, if we have amplitude with some sinusoidal function and initial angle, we are taking, instead of it, complex vector with the same length and the initial angle from our sinusoid. It could be represented in complex form in two types, such called exponential form. Let's look on our drawing. We are taking the amplitude value length from our initial sinusoid and the initial angle. Here is on this drawing without initial angle, but it should be, if draw more accurate, it should be like that. Initial angle and amplitude. These 2 points, these 2 variables gave us the complex vector. And in the form of length and angle, it will be exponential form. In the form of 2 projections, the projection of our vector on the real and imaginary x, these 2 points, will be such called algebraic form. Projections we could obtain at length of vector, multiply on cosinus function to obtain the real projection, and multiply on sinusoidal function and imaginary value to obtain the imaginary projections. These 2 points. And instead of all functions inside our system, we will use only complex vectors. It will make our calculation as much simple as it can, and we will see it on the further examples. And we finished that. I propose you to look through the basic complex operations, because to calculate complex vector, we will use the standard complex operations of such mathematical operators. And moving forward to the basic elements which we are using inside sinusoidal networks. 3 basic elements: resistor, coil, and capacitor. Resistor, coil, here it is, and capacitor. Here it is. They are represented, the 3 basic effects inside circle. Resistor represents any type of consumption, any type of transformation, electrical energy to any other types. And what is its main characteristic? That resistor could be represented using just Ohm law. We could use voltage and current just by the constant proportion between them, and this constant will be the resistivity of our resistor. That is mean that if our voltage is sinusoidal function, then the current will be the same sinusoidal function without any angle difference between them. Just 2 sinusoids, one by one, the same initial angles, because only standard constant R is in proportion between them. In sinusoidal form, it will be like that. And in complex form, it will be two vectors of different lengths, but with the same angle of initial phase. It is quite important because we will use the diagrams of vectors quite often, and it is quite powerful engineering approach to analyze the working mode of system. Then also we could write Ohm law instead of resistivity value in value of conductivity, the opposite value G. Conductivity is 1 over R. And what is more important, that the value of resistivity independent on frequency. For any frequency that we will use, the value of resistivity will be the same. This situation that two vectors have the same angles could be represented in complex numbers in the form of complex vectors, just like that. The variant of Ohm law because if two vectors have the same angle, then in the equation, it will be just only with difference on the proportion of resistivity. Then, quite important situation about power. If we are speaking about power, also we have two different values. First of all, such called instantaneous power. That is mean the value of power in concrete point of time. For this second, for the next second, and so on and so on. For any point of time, we have different power because current and voltage value differs. Power equals voltage on current. If we will substitute voltage value using the Ohm law as resistivity multiplied current, we'll obtain I square R, the standard formula for power. And substituting the current function as sinusoidal value, we will get such function, such representation, and substituting instead of square of sinusoidal function, making trigonometrical transformations, we could substitute sinus square as 1 minus cosinus of double angle divided on 2, on double frequency angle divided on 2. That is why instead of 2 sinus square, we could substitute 1 minus cosinus double frequency angle. And this instantaneous power, as you see, has two parts. First part is constant, and second part oscillating with double frequency. That is mean if we want to find the average power, just average power for period of oscillation, it should be integral function of this constant value and integral function of this sinusoidal function. But cosinusoidal function will give us 0 because if we are, what does it mean integration? It summarizes square under the graph. And as you see, positive square should be just equals negative square for cosinus function. And in total, it gives us 0. Positive and negative neglect each other, and we will obtain 0 second part. That is mean that the average power will equal only R on root mean square value, R multiply on I square, when I is root mean square value. The formula the same as for direct current case. If we'll represent it on the graph, you see current function, instantaneous power function, and the average power rate that could be found from the root mean square value of current. The second main element is coil. It represents us magnetic field, all magnetic fields inside our system. It could be magnetic field from some generator. It could be magnetic field as some load, or magnetic field near any wire with current flowing through it. And to describe the general characteristic of coils, we are using the Faraday's law, which describe the dependence between magnetic flux and such called electromotive force. The electromotive force is a derivative of magnetic flux, and magnetic flux equal inductivity on the current. Inductivity shows how it is a characteristic of magnetic property of element inside system, and it shows how big, how large magnetic field can appear near such element. That is why instead of flux, we could substitute inductivity multiplied on current, and because inductivity in linear circles just a constant, it moves before the derivative operator, and we are obtaining the standard formula minus L derivative of current. Also, magnetic flux function could be rewritten if we have some coil with lots of loops of this coil. For example, if we have a loop of wire and current that flow in this loop, we'll get magnetic flux from this loop. If we have multiple loop system with number of loops W, also from each loop we will obtain magnetic flux, and we should multiply it on the number of loops. That is why in multiple loop system, rewritten of Faraday's law. Why do we need it? Because Faraday law determines what voltage will appear inside our system as a reaction of appearance of electromotive force. For any current change, variable magnetic field appears. For any oscillating current, oscillating magnetic field appears. And for any oscillating magnetic field appears electromotive force. And to neglect this electromotive force appears voltage. That is why as the conclusion for any current derivative will appear voltage on the point on the nodes of our coil. Here it is, voltage UL at the derivative of current multiply on inductance. If we will substitute current as standard sinusoidal function, at the derivative of sinusoid, we will get, first of all, derivative of complex function, derivative of argument inside our function, derivative from omega t will give us omega. From constant, it will be 0. That is why derivative from omega t plus psi equals just omega. Then derivative from sinus, it will be cosinus, or sinus moving on 90 degrees. I is a constant. It could be moved before the operator of derivative, and we will get inductance, omega from operator derivative, constant of amplitude current, and after the operation of derivative, cosinus function or sinusoid, or in other words, sinusoid move on 90 degrees. It will be the function of voltage. It is mean that for coil, we are getting voltage and current moving exactly on 90 degrees, and current lags on voltage, or the same word, voltage lead current on 90 degrees. It is quite useful to compare with resistivity. Let's make it. Why I describing this such detailed? Because we will use these main properties and they determine all further mathematics in complex numbers. Moving for coil, here it is. Please compare. For resistor, 0 angle between functions. For coil, 90 degrees angle, and it is quite visible in vector form. For vector form, voltage and current the same. And for coil, current lags or voltage leads on straight 90 degrees. Then how it could be represented in vector form in the term of resistivity and Ohm law. As you see the equation for coil between voltage and current function, if you are comparing voltage and current function or voltage in sinusoidal form, it differs only on omega L and 90 degrees angle. All the other values are the same. That is mean that in mathematical point of view, we could write the variant of Ohm law for coil only for sinusoidal current. It is quite important that it could be done only for sinusoidal current, but you could write that voltage and current for coil equals in proportion to value omega L. This value omega L is named as reactive resistivity. It is point as XL. In some literature, it is called reactance, but generally, additionally to such called active resistance R, we are called it reactive active resistance R, and X is reactive resistance X. Mathematically, it is the same value in ohms, but it depends on frequency, and also it is quite important thing, because if resistivity for ordinary resistor frequency independent, it stays the same for any frequency. Then for reactance, you see that it is frequency dependent as a straight function, because it just multiplies the frequency. It means if you double the frequency, your resistivity of coil also double. If you triple the frequency, your resistivity will triple. Then it could be substituted in any function. For example, in sinusoidal variant of representation between current and voltage, you could substitute this reactance. In also vector form of complex numbers, also between current and voltage, you could substitute this reactance and write in the amplitude value of Ohm law, or in root mean square variant of Ohm law. Both of these two cases are true and could be used in our calculation of circuit working mode. And also, quite important thing about power. About power for any element, it is multiplication of voltage and current. And in this situation, voltage and current move on 90 degrees. For voltage, you have cosinus, for current, you have sinus. Also, let's substitute, let's compare with resistor. Here it is. Here it is. Let's compare. For resistor, you have two sinusoidal functions, the same angle. For coil, you have cosinus and sinus function. That is mean that multiplication of cosinus and sinus will give you only sinusoidal function of double angle. 2 multiply on cosinus and sinus will give you sinus of double angle after the trigonometrical transformation of such equation. Then instead of 2 parts of power, you will get only 1 power of sinusoidal oscillation. It means that if you want to find average value of power of coil by period of time, after the integration of instantaneous power, you will get only 0, because you are integrating only sinusoidal function with the same squares of positive and negative value, and the total square equals 0. Why it's so? Because we were speaking that coils and capacitors don't consume energy from the circle. They just transform in energy from one storage to other storage inside our system without any adding or disappearing the energy. That is why the total consumption of resistivity could be found as Joule heating, but coil doesn't consume electricity, all electricity stays inside the system. It is the main difference. Also, that is why we are using real numbers for resistivity and imaginary numbers, complex numbers for coil, and also for capacitor. Next time, we will move further for capacitor, quick revision, the same idea, the same formulas, but with the opposite angle. The angle will be not plus 90, but minus 90. And we will move further for general using of this law, general using of Kirchhoff's law and Ohm's law in complex form, and how it will be implemented for practical tasks for calculating the working mode of the system. For today, I think that's enough. And next time we will start from the comparison of these three main elements. You could find the general properties in this table. Thank you, everybody, for attention. Wish you a nice day and see you the next time on the next lesson. Goodbye. And once more, have a nice day.